Welcome to today's Explainer. We are jumping right into the absolute foundation of computer science today, the Master Developer's Toolkit. We're going to focus heavily on the core building blocks of data organization, specifically sorting and searching algorithms. Whether you're a novice just getting your bearings, or you're an experienced learner looking to really solidify your engineering fundamentals, mastering these concepts is absolutely crucial. So let's dive in and see how we can transform raw, messy information into powerful, actionable insights. So think about it for a second. How do we actually find what we need in an endless sea of data? Picture chaotic, unorganized data as our ultimate enemy. When data is just scattered and totally unstructured in lists and arrays, it's essentially useless. It bogs down systems, it frustrates users, and it wastes massive amounts of computational power. But algorithmic knowledge, that's the superpower we need to conquer it. By learning to order and retrieve data efficiently, we literally bring order to the chaos. Here is our roadmap for this explainer. We'll start by organizing the data chaos. Open up the Sorting Algorithm Toolkit. Explore the Searching Strategy Guide. Learn how to choose your algorithmic weapon. And finally, see how all of this powers tomorrow's technologies. It's a step-by-step path to building your ultimate developer toolkit. All right, let's jump right into part 1, organizing the data chaos. A true master developer doesn't just start blindly typing out code to sort a list. First, you really have to stop and evaluate the problem statement. What is your specific goal here? Are you trying to optimize for raw processing speed, or are you trying to save memory? Figuring out those objectives right up front dictates literally every decision you make when structuring your data. It's the most important first step in applying engineering fundamentals. Moving right along to Section 2, the Sorting Algorithm Toolkit. Just look at the sheer breadth of options we have available. We've got foundational methods like bubble, insertion, and selection sort. These are honestly perfect for getting your head around the concept of moving data step by step. But then we step up to the heavy-duty, highly efficient mechanisms. We're talking merge, quick, and heap sort. You absolutely need to know how each of these operates under the hood, because each tackles unordered arrays in a totally unique way. Understanding these nuances lets you match the exact right tool to your specific computational bottleneck. But let's be real, the real world is almost never as simple as just sorting a single list of numbers. So what happens when the complexity ramps up? Well, you need to sort on several keys. This means you're ordering data based on multiple criteria simultaneously. Think about sorting a massive database by geographic location first, and then sequentially by last name within that specific region. Mastering multi-key sorting, along with list and table sort methods, is a total game changer for handling the incredibly complex datasets that actually drive modern apps. Which brings us to Section 3, the Searching Strategy Guide. Now that our data is organized, how do we find what we want? Well, on one side, we have linear search. It checks each element sequentially, one by one, until it finds the target. It's super straightforward, but imagine doing that on a list of 1 billion items. No way, right? It could take an eternity in computing time. On the other side, we have binary search. Because it requires sorted data, it works by constantly dividing the dataset in half to rapidly zero in on the target. Grasping this complexity comparison is essential, because picking the wrong searching concept can literally bring an entire system to a grinding halt. All right, Section 4. Choosing your algorithmic weapon. To really master data organization, you've got to have the ability to explore design alternatives, basically judging every method's ability to work on a specific dataset. For instance, a method like insertion sort that works flawlessly on a small, nearly sorted dataset, it might have severe memory or time limitations when you apply it to a massive, completely randomized table. You have to weigh these design alternatives against their inherent limitations before you ever commit to a solution. All of this builds into a highly practical analytical workflow. Step 1, evaluate the problem and identify your core objectives. Step 2, choose the appropriate algorithmic procedure. Step 3, verify the mechanism and validate that it actually works on your data. And finally, Step 4, represent that data in tabular or graphical forms to draw your conclusions. This right here is the complete life cycle of a developer solving a problem from start to finish. But hey, theory only gets you so far, right? The true validation of your skills always comes from hands-on implementation. You have to sit down, write the code, and watch these sorting and searching techniques manipulate arrays in real time. This is your challenge moving forward. It's through this actual implementation that these abstract concepts of algorithmic complexity finally become concrete, highly practical skills. And finally, Section 5, Powering Tomorrow's Technologies. Literally every single day, our world becomes more reliant on data. Whether we're talking about artificial intelligence, global financial networks, or advanced healthcare diagnostics, none of these emerging technologies can function without lightning-fast data retrieval and impeccable organization. Applying these engineering fundamentals isn't just a classroom theory. The toolkit you are building today is the exact same foundation that is going to fuel the next generation of tech breakthroughs. So, I want to leave you with a question to chew on. As emerging technologies continue to generate unprecedented mountains of data, which algorithm will you trust to retrieve it? The chaos of data is definitely out there, but you now have the roadmap to organize it. Dive in, implement these methods, and build out your toolkit. Thank you so much for joining me in this explainer, and keep exploring.